So, hello and welcome to this live stream. A live lesson basically of a geometry nodes thing and explanations and so on. And I thought, why not when I have time to make this live? So it's a little bit more interactive. Okay, so I will start. So I want to add some spikes here on this cactus. You may have seen that on the thumbnail, and I will have with one eye, looking at the project which I'm recreating now here, and one eye at the stream, and then we'll see how this goes. Okay, so let's just start. I want to add some spikes on this object here. By the way, don't be confused. I just used this from another video of mine. It has a little rig thing that the cactus can wave his hands or something, but I just kept that. You don't need that. That's not mandatory. Okay, so I have a new geometry nodes tree. And here I want to, now distribute points here, because when I want to add some spikes here, then I have to basically have points somewhere on the mesh, like this. You can have this in different ways. So one way of distributing points would be to use a distribute points on faces node. This would add randomly on the area some points, like here. And it would work like that. The downside here would be that they can be very close to each other, and maybe you don't want that. So you don't want to have like overlapping geometry and so on, which means you usually would use Poisson disk on, for example, spikes, because then you have like a distance minimum. Let's make this pretty high here. And then with a distance minimum, you can set a relatively even distribution on the surface here, like this. So I would use that. Alternatively, so let's get this on the side. Alternatively, you could also use the object's vertices itself, because the vertices here are also points. So every vertex here counts also as a point in the geometry nodes editor, and this means we can just use them. As you can see here, they will be relatively evenly distributed also. So you would have like a visible grid of spikes here, but we can also delete them, some of those randomly, so we can of course break that that visual grid a little bit, but we could also use them, and we can just use a so since those are already points, let's quickly I think with this we can see that. Yeah, here you can see it with points. So we can also use the actual vertices, and as you can see, it's very structured here now. It's very nicely arranged as a grid. We could also use this, and we could, for example, delete a couple of those. So we could, after we use, if we want to use this method here, use a delete geometry here, and then everything's gone. And now we will make a selection what to delete, because when nothing is plugged here, everything will be deleted. And then we can use a boolean, a random value on boolean. And then we have a probability, which means a chance of being deleted, if I plug this in. So this gives me a random value. Sorry, it's not a random value. It gives me a 1 or a 0 or 1, so a binary output, depending on a chance. So every point here has a chance of 50% to be either 1 or 0. And this means half of it is being deleted. And then I can just play with it. Should I delete nothing or everything? And as you just saw, when I do it roughly like this, then I kind of lose the appearance of a visual grid or something when I do this here. When I change the seed, I can change the distribution here. So these random values on every point, of course, has a seed value where you can use whatever kind of pattern you want to have. But yeah, you will always stay on those positions here. Let me quickly enable this so you can see it when I go to edit mode. Oh, you can't. Okay. Then it doesn't matter. Okay. Sorry, my throat is a little bit dry because I have like a pollen allergy currently. So I have to drink a lot during speaking. All right. So that's why I won't use this, but you could use it like this. If you have a mesh object where you want to reuse the vertices as points, you can do that. I won't do that here. Oh, gosh. You could do it, but I won't do that. I will use my distribute points on faces on Poisson disk to have my spikes or points or whatever on a not bound to the vertice positions. Okay, and then I can pick a nice pattern here, whatever I want. Okay, so now where I have my positions of my spikes, I can now continue with the spikes itself. The good thing is a spike is basically a cone, so we can just use that or generate that in the geometry nodes editor itself. Of course, you could model one, so you could do this mesh cone and then have a cone here like this one here like this, for example. So you could have a cone, just be careful that the origin is here at the bottom or maybe a little bit below it here like this. And then we could use this cone, but since this is such a simple geometry, we can just create this in the geometry nodes editor. So by this, it's more flexible. So you can use that. Of course, if you have it like this, then you can, of course, modify it a little bit. Like this. Knife, what's the cut through C? So you could then also make it a bit crooked like this, and then we can use this, for example. But yeah, we can just use the geometry nodes editor itself for that. All right. So we can just add an instances on points node because we want to have instances, and instances are copies of something. In this case, of the cone. So instances on all the points, and the instance is a cone, which is here. Let me quickly move that over here. So like this. Now we have that very beautiful Christmas tree looking like thing, or looks like a Pokemon almost. And now we can just choose whatever it should look like. So for example, I think I don't want to have that many vertices, and maybe 12 or something. We can change that. That's a good thing when you have it here. It's pretty flexible. And of course the radius bottom should be maybe like this. Let's see, radius top, and the depth shouldn't be that large. Oh, by the way, I can't see my original model because of course I'm replacing it by doing this, because you can see it here. This node converts the data type. It has a mesh input and a point output, which means sorry. This means during this node here, it changes the geometry type from mesh to points, and by this we lose the mesh, but not a big deal. We can just retrieve it with a join geometry node. Oops, like here. And then I can just connect it over here. And by this, I just bring back the original one after whatever I'm doing here. So that's the method you can use to bring back older versions of the geometry at any point. Okay, so let's continue now. So you can here use your node to change things like that. So I mean, that's pretty large, but for now we can use it like this. And 12 vertices, that's fine. Okay, so, and it's closed with an n-gon, so that's also fine. Okay, so now, as you may have noticed already, the rotation here is not correct because the cones are facing up. which is the standard rotation here, or the standard pointing direction, which is just cone pointing upwards. To change this, we will just rotate the thing. And we can do this here with instances and points, because when we change it into an instance, we can rotate it. Let me quickly see, is this already working here? Okay, so this is already working. That's very nice. It wasn't always like this, that you can just use this data here. So that's basically how the normal is facing here. So that's pretty cool. This is, does it explain it? Okay, it's not. So this is the normal direction as a rotation, which you can then easily use. Very helpful. Before we had to use the normal direction and then just calculate the rotation out of that and then apply it, but here it's fine. We can just use it like this. So let me quickly make a little bypass here so it's not too confusing. Okay, because, I mean, we can just overlap it. Oops, we can just overlap it here, but maybe it's less confusing if you can see where the lines are going. Okay. So, then we have the spikes here. And maybe we want to change something. So that's a detail which I did on my version, but we could, for example, have the spikes point in a certain direction a little bit. So in this case, every spike just points 90 degrees away from the surface, as you can see. But we can also kind of make it point slightly upwards, for example. That's also possible. Let me quickly look something. Yeah, maybe I want to use the normal for that, just because I'm used to doing it. I didn't do it with rotation usually. Can I also just align? Just rotation to vector. I think I want to use the normal for this one here. Yeah, I will use the normal output of the distribute on points node. Sorry, distribute points on faces node. To have the spikes pointing slightly upwards. Okay, so then I just stop talking and start doing it. Okay, so here so let me quickly get rid of this here at first, and then, so I'm very sure you can do it with a rotation as well. I'm just not used to doing it. Usually I work with vectors, not with rotations. That's relatively new also. So rotations were in Blender since 4 point something. Is it 4.0 or 4.1? I don't know, but rotation is relatively new. So I'm used to work with normal vectors and so on. Okay, so we still want to go in here, and we do this with a align rotation to vector, and we connect this then to the rotation. And I want to use it for here. So this is basically what's happening if you use rotation here. But the good thing is here, I can now, okay, now I have overlapping things anyway. Okay, just ignore that. So you can see where it starts and where it ends. Sorry. So we can now add another vector, for example, a vector pointing up. It will result in the following. So for example, let's say we have this spike here. This spike has a vector pointing in this direction. And when I now add another vector pointing in this direction slightly, so this is maybe 1 and this is then 0.2 or something, or 0.3, then it will result in this vector when I add them. This plus this is this, so A plus B is C. And then the spike will point in that direction, slightly up. And every spike will do that. So this spike will be more in this direction, and this will be more in this. And then the general plant will point slightly upwards. And yeah, I just thought that could be a detail which maybe you want to add or something. So how to do this? I just have to add something here, because this is the normal vector, which is this one. That's the normal vector. And now I want to add something else, which is this one. So I just use a vector math and just add the vector which is pointing on the z-axis up, which is 0.3 or something. And you can see that here. So if I slide, you can see that the spikes are pointing up or down depending on how the vector is pointing. So this vector is pointing up pretty far, 1.2. This vector would be neutral, so there is no vector at all, basically, and this vector would be down. You can also, of course, use the other axis, so we could also make them point on the y-axis, positive or negative, for example, or on the on the x-axis here, or on the y-axis here. So this is just, in general, the general direction which I'm adding to the normal vector direction. So, but in this case, I'm fine with just using it like this here. Sorry, I'm coughing a lot. Okay. Okay. So, but now we can see something maybe somewhere here. That, of course, if I do this, then you maybe see the bottom of a spike, for example. And maybe we don't want this to happen, which means I just have to push it a little further inside. I mean, there are multiple solutions for that, but the most simple one would be to just push it slightly to the inside, and then, yeah, you won't see that. Okay, so let's do that. Okay, and I want to do this, let's look at it from here, with another, yeah, vector, basically the same vector, so I have to move everything negatively from the normal vector. So the normal vector, again, is the vector pointing 90 degrees away, where the spikes originally were. And when I now move it, let's say by minus 0.3 or something off the normal vector, then I move them inside. So, and I maybe want to do this after I rotated them, because then they will move in this direction. But yeah, we will figure that out, if what looks better here. Sometimes you just have to try. Okay, so I want to I will just move the instances. So I could translate the instances. I could also set the position. Both would work in this case. Because if I move the geometry... wait a second. Maybe I want to use the instances here. I mean, set position would also work, because I would move every point. So here we have multiple points on that cone. And if I move every point inside of its normal, then it's the same thing. But instances would be easier. And I think better to calculate, or faster to calculate also. Okay. So I will use it here. By the way, here we also, or we again changed the data type, if you noticed that. Here we have points, and after the instances on points, we have instances and not points anymore. And by this, we can use the instances, yeah, the translate instances here. Okay. So I want to use it here. And the translation would be the negative of the normal vector. And now the question is from where I grab the normal vector. Let's say I grab it from here. And then we can see if I can just... it's here. So I think that wouldn't work. Yeah, I think I want to capture that. So let's quickly use a capture attribute. Oops. Oh, sorry. Distribute. I want to capture here. And here I want to capture, is this normal? Okay, we can see if this works. If not, I have to find something else. I want to capture from here. Let's quickly see scale. Okay, let me quickly check. Oh yeah, I did it slightly different. I just have one eye on how I built it before. I captured something different here. Let me quickly just build it how I built that before to show it to you. That's here. So I captured the normal of the faces. Oh, that's maybe the issue. Let me quickly check if that was the issue. Of course, I want the face normals to have here. Oops. Okay, no. Okay, got it. So let's just do it here. Of the points, sorry, not the points, of the original geometry here. The normal. Is this the issue? Local space. Ah, okay. Is this rotated? No. Okay. But yeah, I want global space, so that's fine. Okay, I just checked off local space. But then this should also work. Let me quickly check. That should also work. Face. Ah, my gosh, experimenting live also always a great thing to do. Okay. Okay, so that works. Everything's good. Okay. Sorry. Also, so now I have this. So let me quickly show you what happens here. So what I'm just doing here is from the original geometry, from the original cactus or whatever object you will have, I took the geometry and read the normal vectors of those, and then I scaled the normal vectors slightly negatively, like or minus 0.1 maybe. that's maybe a lot, yeah, but we will see. And then I wanted to move all the instances in that direction. That's it. And now you don't have that because you can see that here they are slightly inside now. Give me a second. Okay. So the spikes are inside now, and this works pretty well. Okay, and now we can, where is my other, here is my vector, which I'm adding here, and now you can see it's not overlapping somewhere. And we can get a bit higher. So like this, for example. So if you want to have like spikes which are pointing up, or spikes which are not pointing down, because those also try to point up as good as they can with the extra vector. For example, like this. So this maybe a more aggressively looking cactus or aggressively looking spikes in comparison to before. And this is then a sad one, yeah, who got rejected or something. So that would be a difference if you want to make a character or whatever. But I will stay with the aggressive one, I think. Like this. Okay. All right. So, oops. Here. Okay. So let's continue with the cactus here. Okay, so far so good with the spikes. And we can also make the spikes a bit more detailed, or yeah, not detailed, but a bit more character to make them a little bit more crooked and yeah, a little bit get the make it more wavy or however you want to call that. So because now they're very uniformly shaped also, and they maybe look a bit unnatural because they're so straight and just uniformly structured. So to do that, after we translated the instances, we can change the appearance of them by just randomize the geometry of those. And we can do that with a set position node. Sorry. Because the set position node is, yeah, with the set position node, you change the position of the vertices. And you can imagine it like this. If you have a spike like that, let's say with a couple more points between it like this. So you have 1, 2, 3, 4, 5, 6, 7 points, and you move them slightly differently. So this point is then here, and this point is here, and this point is here, and this is here, and this is here, and this is here, and this is here. Then the spike is looking like this then. So a little bit different. If we move the points slightly around randomly, or almost randomly, and we will do that now to every spike differently with set position. So we place the node inside, like here. And now we want to say, so the position would override the current position, and the offset here will add another vector to every position, so to every vertex. This is what we want to use because we don't want to override it, we just want to change it. This is why we use offset. So we will use a noise texture for that. And we will plug it. So we will use the color because then we have 3 different values. Color RGB are 3 values, RGB, and they will translate into X, Y, Z, and then this also 3 values, which means this suits perfectly for using it as a vector, like this. So that's perfect. And then we will change the scale a little bit. Maybe you can see that if I do it like this. So the question is now, what the hell is happening here? They all move the same way. That's because, let me quickly show to you how it looks like, because it's not showing you that. So I'm using the position vector in the noise texture. And here the thing is, this has only positive values, which means the R, G, and B value are all positive. So they're from 0 to 1. Which means when I convert them into X, Y, Z, they are all positive as well. So the addition is always positive, which means it will be going into X positive, Y positive, and Z positive direction, which is exactly this direction here. So they're all moving into X, Y, and Z positive. So in this case, right to the back and up, which is exactly this direction here, which you can see. So I want to change this. So I will just subtract with a vector math, subtract 0.5 from every value. And by this, the range of all the 3 values is not from 0 to 1 anymore, but from minus 0.5 to plus 0.5. So that's the range. That's not a minus, that's a from to symbol. So that's the range. And this means it's not moving in one single direction anymore. And in order to have the detail on them, I have to change the geometry here also. So when you look at a spike, I don't have any geometry here, which means I have to increase the side segments, like this, for example. Then I have some geometry to work with. Maybe reduce this a bit more, and like that. Okay, so now I have a lot of geometry to work with. And now, let's take a look. If I change the map here, oh, and it's way too strong also. After I subtracted that, I also want to multiply that. Scale is multiplying with all three vector coordinates at once. Scale it down, the movement. So to 0.2 maybe. We will see what works here. Okay, let's see. I think I made a mistake. No, it should be... Oh yeah, wait a second. Ha ha ha. Before I do that, I have to realize them, because the set position node changes the positions of the instances only, because the instances are not real geometry yet. If I use a realize instances node here, then the instances become real geometry with real points, which I can then change the position of. So don't forget realize them before you do the set position, then you will see it. Okay, and now you can see the noise texture applying on them like this. These the larger the noise texture is, the more random they move in a certain area. Yeah, which means this is like a uniform wave, as you can see, and when it's very high, it's super random, which means I don't want it to be too high. So maybe this could work, or a little bit more maybe. Yeah, that could work. Okay. So we can ignore the rest here. And then here I change that. So 0 would be no change. 1 would be the standard vector, which is too much. But maybe, yeah, this kind of also could look cool, I think. So let's make it a little bit. Yeah, so 0.3 maybe was a good value. And by this, we have now these randomly distorted spikes. Okay. And now we can give them a value, before we continue, we could use a set shade smooth node to get rid of the visible faces here. Set shade smooth here. Okay. Okay, let's get to materials. Yeah, I already gave this cactus a material of a normal map here. Relatively standard, but the spikes are of course also important. So let's go. Of course, to use a set material node, usually you have to also use it here. And then for the spikes also, this is also prepared here. Spikes, so the spikes are just yeah, it's just a principal BSDF node, basically. Yeah, like nothing special. Hi, Saint CH. How are you? Are you enjoying the show? If you have a question about something, just ask. I'm here to interact. Otherwise, I would have recorded a video. But of course, this will also be a video afterwards. So yeah, this is a pretty standard shader material. All right, so let's get back to the geonodes. So this is how it could look like, yeah, a bit inflamed or something. Yeah, we could also leave it relatively neutral like this, for example. Okay, so this is how it could look like. And I also, I prepared two things for that cactus. The first was the spikes. which we did now here with that tree, which is slightly going up here for some reason. And another one will be hair. So we can also add some hair on the cactus as well. Oh, by the way, and the cool thing is, since this is procedural here, you can of course change anything. So for example, if you want to have more spikes, you can just decrease the minimum distance a little bit, and then it will get more spikes. So like this. That's of course a nice thing to do. Yeah, that's maybe a little bit high. Let's leave it on 50 or something. So like this. And you could also see how it looks like. Hello, mist render. Mist render. Is it mist render? Rendering mist is pretty hard because it's volume. Volume is always, yeah. You need to have a good graphics card for that. If you want to render fog and other volumetrical things. Yeah, so we can change procedural everything, or the vector for the happy or sad cactus. Yeah, when he's happy, he's like this, or angry and sad, it's like that. And also he's kind of bald then because I didn't adjust that enough. So let's just leave it like this because he's angry or happy or whatever. Okay, so we got everything here. And so I mean, we could now come to the hair of the cactus. Yeah. Oh, by the way, we can also make the spikes wiggle or move within the within the noise texture, because here I'm using the position as a vector. But of course I can add here with a vector math. You've seen that if you've watched videos from me, you can see that many times. If you move here a vector or an axis here, you can make the spikes move in this. Because I'm sliding on the noise texture left and right in this case, or on the x-axis, and by this they will wiggle a little bit. And it doesn't matter which one you pick here. Visually, they behave the same here in this case. Okay, so you can do that. It almost looks like a parasite, yeah, like the cactus was infected with a parasite. And it's wiggling now. Okay, so we can come to hair, which I will just join on here. So this is the spikes. Oops, spikes. And then we can do a hair thing here above, except someone says, no, I want to see you doing X. Then we can also do something else. But I've prepared this if nobody stops me. All right. So for the hair, let me quickly take a glance. So of course hair will need more computing power because hair needs to be a little bit more detailed. But I think it will work with me being on stream. I think my CPU won't get cooked. Okay, so I want to again distribute points on the faces here because of course hairs have to be distributed somehow. So distribute points on faces. Then let me connect this already here. Then we can see that. Or can we? Oh yeah, we can. Okay, so these white dots here. So those are the points distributed on the surface. And you want to have a lot. And we can use random here. For hair, Poisson disk, I think it's not necessary. Random will be fine. On hair, yeah, it won't be noticed if they overlap. So we need a lot. So maybe like this. Looks like styrofoam now. You can also use this as an effect. And we want to add a mesh line here because a mesh line suits very good for hair, I think, because it's just a line consisting of vertices, like this, for example. So instances on points again, and we will use the hair. Oh, here. And we'll use the hair, the mesh line for hair, and then it looks like this. Let me quickly change this. So the endpoints should be not that high, and I don't want to have that much count. Let's say I want to have a count of 5, maybe. Okay, and then same thing. I want to use the rotation of the distribution to the rotation of the instance, and then it looks like this. And then this is way too long, so let's make it smaller like that. That already looks kind of like hair. But of course we will change that. But it could work already. So oh yeah. So then I want to also change, of course, the position of the points of the hair. So every hair now has, which hair I can grab here, this one. So this has now 5 vertices, which means 1. Wait a second, you can't see that. Here. So let's say a hair like this, it has 1, 2, 3, 4, 5 vertices on one hair, and I want to move them also in random directions to make the hair a little bit more like this. So let's do that. Set position. Basically the same thing as we did here. So we could also copy that whole thing, but let me quickly just redo that. Noise texture. You know what? I will copy that. Like this. With Alt P, you can separate it from the group. So I don't need that. Like here. Okay. Okay, let me quickly see. Realize also. Don't forget to realize that, otherwise it won't work. Okay, so if you take care, you can see that the hair is moving. Yeah, or I still need the scale here. I don't want them too high. So the scale should be 0.2 maybe, so they move a little bit around. Oh, that's good. So like this. And you may notice something. Because Amir, you can't see that, let me quickly use a curve to mesh and then a curved circle with a resolution of 5 maybe and a radius of 0.01. Okay. And be a little bit thicker like this. Where can we see it? Here on this hair, this one. Here you can see that it's detached from the surface. And that's not good because we don't want that because it looks a little bit broken, which it is. And okay, how do we solve that? We just have to prevent, we have to prevent moving the last vertex here, because originally it was like this, and then I moved that randomly around, and this thing here is, it has indices for every vertex, which means this here, I'm not sure in which order it is, but I will just assume that I know it off the cuff. So this is, let's say 0, 1, 2, 3, 4. And I could say, please set position, only set the position or change the position of vertices with an index of higher than 0, which will be only these here. And the 0 will be, it won't be touched by the set position node. And by this, it will always be where it spawned. Okay, let's do this now. So that's in theory how, what I thought about what would work, and it worked. So I will just stick with it. If you have another idea, you can of course tell me what will also work or maybe work better. But I, just did it this way and it worked pretty good. Sorry, just have to take a quick sip of water with a little bit of lemon. Okay, so what I have to do now is to have something in the selection plug here, because this will do whatever it does only to non-zero values at a specific index. So we just have to bring the indices of this mesh line to it being, so those have to be 1 or not 0, and this should be 0. So, and then I can just use the following here. Let me quickly take a quick glance. So I have to, before I realize them, because you have to know also the following, so you have to know a lot if you want to do it. So if you have multiple of those, let me quickly just make it like this. So if you have multiple of those hair, so when it's realized already and this is real geometry, then it will be instanced like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So it will just continue indexing them. I mean, that could that could also work, because then, for example, all these roots will always have or can be divided by 5, for example. And they also can have something in common, because you always have to look, if you want to build procedural systems, you always have to look for rules which apply for specific areas which you want to change, in this case the roots of these hair. But it's way easier to just look at the original index, so this one here, before I apply it, so before I realize it, and here it's like this, and here I can just say, okay, higher than 0, that's it, and then it will apply for every other one if I do it correctly. So we can do it after realize instances, but it's way easier if we do it before. Okay, so now I talked a lot. Let's do it. Okay, so but just I want to explain it pretty well. So I want to capture an attribute before I realize it, which is the index. So now I can bring the information before the realization to after the realization. So I'm skipping this, but I can use the data from before. So that's a cool thing. Capturing things from former geometry, that's very, very helpful, and you use that all the time if you build like procedural systems, because I lose some information in the process, and then with this I can bring it back from a former geometry type or for something. Okay, because here it's an instance and here it's a real mesh. That's the difference. You can't see it here, but it changes it from instance to mesh when I do this here. So now I want to use a, we could use a compare node or a math node, because they both do the same thing. Because here you can say, for example, greater than. So you could use both. I think I will use the compare node, because the result is pink, which is the Boolean data type. Okay, so and I will use the index, and I will just say if the index is greater than 1 or greater, yeah, we'll just see if it works here. I think it could also be greater than or equal than 1, because 1 should be converted also. It looks like it worked. Let me quickly move my texture a little bit. Yeah, so you can see now that the roots of the things here, of the hair, stay where they are. And only the points above them basically move. Like this. So by this we can see this worked now. And they're pretty thick, so let me quickly correct that by changing the radius a little bit, like that. Okay. Okay, I could also set, I think I can, before mesh line. Okay, I would have to use the outlet data. Okay, yeah, I will just leave it at a uniform thickness. That's a bit easier. So, okay, by this we can have like a little bit randomized hair. Let's see. So, and when you have many hairs, you can see pretty good that when the scale is 0, it's not changed, but if the noise texture increases its scale, they move, so you can almost see the noise moving over it like it's in the wind. And when it's more and more, so if the scale is larger, then they get more and more randomized, like this. Okay, so we could live like 10 or something. So they are then randomized. And when you increase the mesh line, oh wait a second, let me quickly, okay, that's 5, that's good. If you increase, because currently we have only 5 of those points per mesh line, we can of course increase those 2 to give it more resolution to work with. So more geometry to work with. Yeah, the downside is it's very slow, but yeah, if you render it, it's not a big deal. So here you can see it when I move it like this, for example. Okay. Could also, so we could also do is to make it more smooth, is to don't increase this here, but to, before we turn it into a curve, which is here, use a or we could also do the curve, but I would subdivide the object here. So the mesh. And by this, it looks more smooth because it just subdivided once more. You can see the difference. This point is then subdivided into these 2 points. So by this, it's more, yeah, curvy and smooth and not that edgy. Like this. Okay. So that's fine. Then, of course, sorry, we can, of course, set the material here, and I also have that somewhere here already, to hair, but that's maybe a bad color for hair, because you can barely see that. Maybe it should be a little bit more bright. Maybe like this. Okay, so it could look like that. Looks a little bit fuzzy, almost like a stuffed animal or something from far away. If you're up close, it looks not that good. So then we have that fuzzy little cactus thing here. Let me quickly get rid of the annotations. Okay. Yeah, one thing maybe interesting here, if I move the rig... wait a second, let me quickly disable the hair, it's too slow. If I move the rig, it will, as you can see here, change the points. So the spikes in this case. This is because, of course, I'm changing the area. By this, it's getting distorted a little bit, the surface area. And by this, it changes the area, and this changes the distribution. So you wouldn't have that issue if you would use the original vertices, which I showed right at the start. Get rid of here. No. Like this. If you use the mesh to points instead of distribute points on face, so if you do it like this, oops. That's also funny looking. Then you don't have that problem, because then the points don't change. So if you, we can see that not very nice. Let me quickly get rid of what kind of, it's this one. No, it's not. Here it's this one. If I mute this. Wait, why is it only... okay, got it. Of course, I need the normal also in here. That's okay. Now I can see it. So here you can see that this here is not deleting the points or whatever, or creating new ones, because here I have a predefined set of points, which is the original geometry, the original vertices. So if you use the original geometry, this can be done without changing the points or whatever. Okay, let's quickly go back because I liked it better before. Just wanted to show you that it could be done. Here. Okay. So, okay, so that could look like this. The hair are maybe a little bit long. Let me decrease the scale by just decreasing the length of the mesh line here. It's hard to dial here. 0.05. Well, that's maybe a bit better. Okay. And if your computer is strong enough, you can increase the density here a lot more to 1000 maybe. And it's like this. Okay. Let's look at this in cycles, because in Eevee everything looks a bit bad. It looks okay. If you don't look too close, it looks fine. So this is how you could render that. And then we could make the spikes. The spikes are maybe a little bit too strongly distorted here. I think I want to make this a little bit less. So maybe like this here. And we can also make them a little bit smaller at the root by changing the radius bottom a little bit, like this maybe. And then they are like that. Okay, I like this a bit more. Before it looked more like a parasite infestation. Okay, now it looks a bit more like spikes. Okay. So yeah, that was basically what I prepared to show. We could, and of course, yeah, we can change the material and everything here with the spikes. Originally, I had it like this because, I don't know, it's a nice contrast between green and red, but maybe that's a little bit too much. I don't know. Yeah, but you can pick your favorite color. I will leave it like this. Looks the most aggressive. Okay. So that's the fuzzy cactus. So basically everything here is the hair. Control J to join, and then that's the hair. So you have here the spikes and here the hair, and then you can overview what you did very well, like this. Okay. Do you have any questions or something? Otherwise, I think I'm finished. I came through pretty well. Yeah, roughly 1 hour. That's what I approximated. Yeah, that was the little lesson about surface elements like spikes or everything else, spikes, hair, or whatever. You can replace that, of course, pretty easily. For example, you could, instead of using a cone, let's just, I don't know, use an icosphere with a radius of, let's say, 0.05, and then use this instead. Okay, it's inside. Okay, let's make this a bit larger so we can actually see them. Like this, maybe. So, of course, you can also use different kinds of yeah, it's just a sphere, basically, a ball, which you can use instead of spikes. Yeah, this also looks kind of cool. Like little bubbles or whatever. So you can also use all kind of things. Maybe with a transmission. Like this. Low roughness. It looks like droplets on it. Yeah, so that's what you could do. Just replace that with anything else. I actually like this, I think, a bit more than the spikes, because it looks a bit more peaceful. like this. Wrong here, like this. And then you can have little bubble thingies on that. Okay. High Infinity 3D. Hope you're enjoying the session here, the lesson. Yeah, we're talking about geometry nodes for surface elements. Yeah, for example, spikes or bubbles or whatever, and hair in this case. So hair and spikes / bubbles. So I have to update this, I think. Or droplets. Like this. Okay. So this has to go in here. Cone is then the alternative. Let's just use the icosphere for now. So, okay. Any question or something? Or something you want to see, maybe? Maybe you want to see something which you always wondered about how to do this or that. Here, it would be perfectly, of course, in a surface context. Okay. Okay, so then, yeah, I'm done. I'm through. We got 1 hour and 2 minutes. That's fine. Yes, and maybe I will do another live stream at some time. I kind of liked it. It's pretty cool. And when I have time, we can have another one. Okay, so then I will close the stream now, and I hope you had a good time and learned something. And see you soon then. Bye bye.